Hello and welcome, everyone. Thank you for joining me here today to talk about the new features and approvals on our PD9000 Plus multivariable controller. Everybody here at Precision Digital is really excited to be rolling out these new features and approvals on the ConsoliDator Plus. They have been under development for quite some time, and some of the features that you're going to see here today, such as PID control and the switches, have been asked about really since day one of the launch of this product. So I am happy to share them with you. I think you're going to find them really exciting. Before I get into the bulk of our content, however, there's a couple of questions and comments I always like to address up front. The first one, of course, is that you have probably noticed you are in listen-only mode. By that, I mean you aren't participating on the call. You can't be heard if you're talking to your microphone or your phone. And that's because there's just simply too many people on the line to make that viable. However, you're going to have questions as we go through this today. And if you do, then I would encourage you to type them into the Q&A feature. There's a Q&A button on your Zoom taskbar, or you could send them in as a chat as well. I'll be monitoring both, and periodically we'll stop to answer any questions or comments that may come up from you, the audience. The most commonly asked question I get is about getting a copy of the slides or having a recording of the webinar. And the answer to both of those questions that inevitably are going to come up is that you can get a copy of the slides, and we will be sending out a recording of the webinar. Those will be automatically sent out to anyone who registered for the webinar, so all of you included, and will probably go out either tomorrow or Friday. Lastly, personal request, if at the end of the webinar you see a survey, if you could take a minute to fill that out, I would very much appreciate it. It makes my life easier because that's the survey we use to get feedback. What did you think of the webinar? What would you like to see in the future? Do you have any other interesting comments you might like to share about what you liked, didn't like, what features you'd like to see us develop, what kind of topics you'd like to see in these presentations? I get really valuable information if you can share your comments there. With that, why don't you allow me to present myself? So my name is Joe Ryan. I'm the VP of Sales and Marketing at Precision Digital. And I have been with Precision Digital for almost 20 years now, originally as a product development engineer, and then eventually as a product marketing engineer, and inevitably VP of Sales and Marketing. So I have a pretty broad base of understanding as far as the products go, as I've been on both the design and the application side of them, which makes me fairly uniquely qualified here to talk about our products, where you can use them and how they get deployed out in the field, how they get sold, what kind of applications they're ideal for. Our takeaways for you today are to be able to sort of quickly see an overview of the PD9000 ConsoliDator Plus. Sure, this presentation is about the new features, but I think we're going to see in a moment that many of you could use a little bit of a refresher as to what the product is, and so we'll spend a little bit of time on that. I, of course, want to introduce you to the new features. That's the reason we're all here, and the new approvals as well. And as we do that, we're going to want to show you, how do you take advantage of PID control? What is that? What's it look like in a real application? What are these switch functions, and how are you going to use them in some pretty common ways? And then lastly, we'll talk about actual examples of those PID and HOA switches, and what all that means, of course, will be covered. And we'll see some basic block diagram application drawings to help connect the dots about what these features allow you to do. Now, the first thing I want to do is cover that quick overview of the consolidator. And to do that, it would be helpful for me to know a little bit more about you. So I have shared a poll. I'd appreciate it if you'd give me some feedback on that, because it's going to help me understand not only what your role is, but also what your experience level is with the ConsoliDator Plus. And I can see I've got all kinds of answers coming in here. I'll give you another minute there. I'll use this to shape what slides I show and how long I dwell on this topic of the ConsoliDator Plus, whether or not we talk about the demo unit, for example. In this case, it looks like roughly 50% of you are actually from our distribution channel. So I may throw one slide in there to talk about the demo near the end, but don't worry if you're not one of our sales folks, you're not going to have to sit through anything painful. And as far as expertise, nobody today is claiming to be an expert, but it does look like about 70% of you say that you have some basic understanding on the product. So we'll cover it a little bit here just as a refresher, but we won't dwell too long on what is a Consolidator Plus, but we'll just briefly touch on it. So I thank you everybody for participating in that. So let's jump in and talk about what the Consolidator Plus is and what the features are, including the new features that are brand new, just getting launched this month. I'm going to unshare my video so I can focus myself on drawing on the screen and keeping your attention there. So for starters, what is the Consolidator Plus? Well, the Consolidator Plus is a NEMA 4X panel mount multi-channel display and controller. It is NEMA 4X panel mount, meaning that this entire Consolidator front that you see here on the left gets installed in a 10 by 10 cutout in the back of the panel. And it has a nice large gasketed bezel. There's a gasket on the other side of that plastic bezel that's going to keep it with a NEMA 4X seal to your panel so it's waterproof and dust tight. We call it a multi-channel controller because you can bring all sorts of inputs and channels into this thing. For example, you can get up to 28 4 to 20 milliamp inputs, but you could also bring in, if you wish, you could have versions of it that take in pulse inputs, usually from flow meters. You could have it accept Modbus variables, either as a master or a slave. Great for Modbus multivariable transmitters. Those 4 to 20 milliamp pulse Modbus signals can really be almost any application you can think of: flow, level, temperature, pressure, gas detection, proximity, you name it. And it can also have 4 to 20 milliamp outputs and relays. So that gives you the ability to do alarming and control, as well as signal conditioning, and you can send that information back to your SCADA system, however you'd like. So there's a lot this product can do. Those channels have the option of being displayed on a 5.7-inch color display. It's a fully graphical backlit LCD that you see here. And this is an actual screen picture. So you can see in this case, we've tied together our tanks and our bar graphs so that you can easily just color code things and tell what is what and what matches up with what text. And you'll notice that the resolution on the screen allows us to use real text language here. We're not using 7-segment displays. It's not some kind of dot matrix setup. You can easily read, this is tank level, tanks 1 to 4. This is tank 2 water. It's displaying in gallons. We've even got commas and decimal points in those numbers, all designed to make it a really crisp, clear, easy to read display. With those relays, you can do all sorts of display and control, or mostly control, obviously, features. You can have alarms. You can have those alarms based on highs, lows. You can make math channels and then have those relays based on there so that you can do operations such as rate of change alarms or ratio alarms. You can do pump control with this, pump alternation. Really broad range of what you can do with these relays, some of which you've seen in our panel meters before, but much, much more than that. And to give you a sense of what that much more means, we've got 32 timers in there you can use to control all sorts of processes and events. So you want something to happen at 8 a.m. every day. You want it to happen after 12 hours. Every 10 minutes, you want to take a sample. And I specifically mention timers because really what we promote the Consolidator as is a PLC and HMI combo that you don't have to write code for. If you've used HMIs and PLCs in the past, you know that either you've got to be an expert at them, you've got to write the code for the PLC, you've got to define the fonts and the graphics and the pixel locations for that HMI, or you've got to pay someone a small fortune to write you a bunch of code to do it that they're then going to own. And now you're beholden to them for the rest of the application's lifetime, because you want to make a change, they've got to do it. Well, if you need those kinds of products, but you want to be able to program it yourself, you want to have your operators be able to do it, then the Consolidator Plus is what you should look at, because if you can program a panel meter, you can learn to program the Consolidator Plus. And yet you're going to have something that looks a lot like an HMI and has most of the features you're going to be using in a PLC. Now, that programming can take you a while if you use the front panel push buttons, of course. Even just typing in, I want tank 1 water to be my tag, can take you a bit of time. So we do have free Consolidator Plus configuration software available. So you just connect this up via USB, download the software off our website, and you start programming. Those are all existing features. Let's talk about what's new. That's why we're here, of course. So we are now UL and CUL listed on the Consolidator Plus for hazardous and ordinary locations. And if you're asking yourself, what's the difference? What the heck is CUL? We'll get all into that in a minute. We have auto-tuning PID control for multiple control loops. So this doesn't just replace one quartered-in PID controller. This will replace at least, I'd say up to 8. You can go beyond that. It just gets a little tricky in the programming, but at least up to 8 PID control loops is fairly easy to set up, and we give you all the information on how to do that. And your output for your PID can be controlled via our 420 milliamp outputs, our analog signals, our digital outputs, or our relay outputs. So whether you're doing 420 outs to power controllers or pulse outputs from the digital outputs, or maybe you want to just have a relay tripping on and off on cycle time, time proportional, pulse width modulated type control, great, we can do that as well. We've also added all sorts of 2, 3, and 4-way switches, including HOA switches, and we'll cover what hand-off auto or HOA switches are in a bit, but very common in pump control applications. And we now specify models to either be AC or DC powered. This is the one sort of negative of the UL listing, is the UL did want us to break out those power supplies. So whereas in the past your consolidators would have both high voltage and low voltage power options, now you have to specify if you want it to be high or low voltage. So that's the gist of what's new. And if you want to learn what is new, and if you want to learn more about that, then stick with us. Looking at the back of the Consolidator Plus is also helpful because it gives you a sense of what this is capable of. Here on the left, you'll see that there's 7 card slots. And these cards can be swapped out in the field. That's a common question we get. In fact, here it comes. Someone's already asked, can I swap out these cards live in the field, or do I have to buy a configure from the factory? Well, the answer to your question, Tom, is that we prefer you buy it like this from the factory. It's easier for you to do that, to get it pre-populated. But then if you want to add or change something in the field, that is possible. But you have these 7 card slots, and those can be 4 pulse inputs per slot or 4 analog inputs per slot. The analog inputs, just like the analog outputs, both come with 24-volt isolated power supplies, 1 for each channel. So you get a 4 to 20 milliamp input card. You also get 4 24-volt isolated power supplies. Or you can fill it up with 5 analog outputs, that's 4 to 20 milliamp outputs with power supplies, or 5 relays per slot. You can see there's a lot of different combinations of pulse, analog, relays, and 4 to 20 milliamp outputs that I can put onto this to really customize it and build it for the needs of your application. Now on the right-hand side, you'll see that we've got digital inputs. They're great if I have, for example, discrete inputs coming in from float or flow switches, or maybe I have a remote control station that I want to connect up and have those cause button functions to occur, like acknowledging relays or clearing totals. We've got an Ethernet option. So we now have Modbus Ethernet on a product, and that product is the Consolidator Plus. It's our first and currently only product with that. And what's really nice about it is it is a separate bus to the RS-485 connection. So oftentimes what I'll see with the Ethernet is they want to use the wired 485 bus to go out and connect to multivariable transmitters where the Consolidator Plus is a master. But then they want to have something in the cloud or perhaps a server in the same plant connecting to Ethernet, where in that case, the Consolidator Plus is going to be the slave. We can be the master or the client on the wired bus, and we can be the slave on the Ethernet bus. There's a micro USB port that comes standard for connecting to the software, digital outputs that come standard, which are great for driving simple signal outputs, things like you want to send a motor start command, or you want to send a alarm signal back to a PLC's digital input. And of course, we've got the 485 standard, which by standard setups can be used as Modbus slave, but you can buy a Modbus enhanced feature suite package, which lets it do all sorts of cool other things, like be a Modbus master to pull data on the bus, or you could have it be a Modbus snooper or a packet sniffer, where it just displays information being pulled by some other master. So if you use Modbus, I can't tell you enough how much I think you would benefit from really learning the Consolidator Plus. To give you a sample of what you can see on that screen, you can actually have up to 8 pieces of information displayed. In this case, we're just showing you what 4 would look like, but you can put up to 8 on there. And as you add those, by the way, it automatically resizes and changes. So here, for example, we've got a basic screen showing a screen title, 4 channels on that screen, each with a label, a unit, and the number. We've turned on bar graphs for each one of those channels. And you can see the alarm points for each one of those bar graphs. Programmable soft keys at the bottom can be programmed to be whatever's applicable for that screen. So in this case, we've got navigating left and right to go through different screens. You can turn the automatic screen scanning on or off if you want to leave it at one screen and not have it automatically cycle away. And we have the ability to acknowledge our relays. Now, to give you a sense of how easy this can be to program one of these displays, if I wanted to change it from the top to the bottom display, where on the bottom you see we don't have bar graphs, I literally just need to uncheck a checkbox. I go to the bar graph checkbox, I uncheck it, and it will just automatically resize those 4 channels to display them in a block format without the bar graphs there. On the right here, you see a channel detail screen. So while it is nice to see it all grouped up together, I may want to then see more details on that channel. So I can hit my right arrow and I can move over to a channel detail screen that in this case is going to show me tank 1. Again, it's unit, it's number, but then also what input it is tied to and what the current input levels are. So in this case, it's telling me the milliamp value of that analog input, and it's showing me whatever alarms are tied to that channel. It's showing me how long has this alarm been on for, what its current state is, what the set and reset points are, as well as the bar graph for display, just so again, I have a sense of what I'm looking at. And finally, in the lower right, what I'd like to point out is that you can have those colors change in alarm states. So you'll see here that I have an alarm state active. And so I have my alarm state line, which tells me where it goes in the alarm. But now that my alarm is active, I have a vertical bar there that shows me the deadband and when it's going to reset. And when you enter that alarm state, I can have the bar graph, the text, the background for that text, change color, flash, do all sorts of things to draw your attention to it. And we automatically give you an alert button on the lower left. You can push that alert button and it'll tell you what alarms are active. The soft keys are configurable to do all sorts of things. These are very basic configurations I'm showing here, but it's worth noting that you can not only acknowledge relays, you can simulate channel changes. So I could cause the controller to think that its inputs are going up or down. I could put outputs into manual control mode. You can acknowledge specific relays or jump to specific channels. All sorts of things you can set those soft keys up for, depending on what your application needs. All right. And again, you're going to set this up with your free configuration software. Easy to download online, connect it up via USB directly to your ConsoliDator Plus. And though it is not strictly the ConsoliDator Plus, it is worth noting that we do have a line of enclosures for these products. So if you want to put it in a panel, but you don't have the panel, well, we offer a line of NEMA 4 steel and NEMA 4X plastic enclosures, where the X, by the way, is corrosion resistance. So though it is a painted steel enclosure, theoretically, steel rusts, and therefore it doesn't have the X. But that's why it's only NEMA 4 for steel and NEMA 4X for plastic, and plastic is corrosion resistant. And we offer enclosures that will hold one ConsoliDator Plus, and perhaps most importantly, come with that 10 by 10 cutout already in the panel for you. So now all you have to do is drill your conduit entry points, and you're good to go. They're available in a variety of sizes, all depending on how much extra space you need to put other things behind that panel. Before we go on and look at the new features a little more in depth, I do want to address a couple of questions that I've gotten so far. So one question is actually submitted from an anonymous attendee, and they're asking, do the timer functions provide flow totalization, i.e. flow rate over a determined amount of time? Can total be displayed and assigned to an output or relay? So the answer to your question is yes, we can do flow rate totalization. You don't actually have to use the timers for that. There's total function that is its own function, and you just direct it to a rate channel, tell it what units you want, and it will display and monitor that total for you. And If you then want to have some kind of a relay or an output assigned to that, that's perfectly fine. You can have a relay assigned based on when a certain amount is totalized. You could have that relay assigned as a sample relay that triggers every so much total that has been accumulated. You can have 4 to 20 milliamp outputs that are scaled across that total. You can have timers that, for example, reset the total for you at a specific time of day. All sorts of nice totalization features you can do. And so the answer to this is yes, you can absolutely do all those totalization features. You don't use the timer just to set up a simple total. You just have a total option for that. It's its own function. And then Jonathan is asking, to sort of paraphrase your question here, there are power supplies that come with every 4 to 20 milliamp output and every 4 to 20 milliamp input. So all of your analog input cards and all of your analog output cards all have a power supply for each channel. So for example, the 5 analog outputs give me 5 isolated power supplies. And he's asking, how much current can I get out of the power supply? So every channel can provide 200 milliamps of power, so long as in total your Consolidator Plus is not outputting more than 1600 milliamps of power. So long as you're not going over 1.6 amps of total current being put out of all of these 24-volt power supplies together, you can get up to 200 milliamps out of any individual supply. And I don't know why exactly you're asking, but to note I will note that is enough to run any 2-wire device, and that is almost enough to run every transmitter out there. The main exception I've run into is gas detection. Some gas detection units can run off of 200 milliamps. Some, especially including inrush currents, become real current hogs, and they want their dedicated 24-volt power supply to be able to provide them 500 milliamps, an amp and a half sometimes. And so if you're doing gas detection, you want to keep a good eye on that. But if you're not talking gas detection sensors, I found that 200 milliamps is essentially enough to run almost any transmitter I've run into. So let's dive a little bit more into the individual features, and let's start with the approvals. So I mentioned that we are UL and CUL listed. UL stands for Underwriters Laboratories. They're a company that does certifications, and they list products or recognize components. CUL is also Underwriters Laboratories, but it is the Canadian approval. So when you see this mark on the product, what it's saying is that it is a UL listed product both to US standards as well as to Canadian standards. UL and CSA have interagency agreements, so UL can test to their Canadian standards, and CSA, the Canadian Standards Association, has a US mark that it can put on things to test it to US-based standards. And so this has UL listing for both Canada and the US, and that listing applies to both hazardous area locations and ordinary locations. Everybody gets what the hazardous area is. That's where you've got explosive or flammable materials around. Ordinary locations where you don't. That's your safe area application. For hazardous area, we've got Class 1, Class 2, Class 3, and for Class 1 and Class 2, we've got Div 2 approvals. For ordinary locations, we have UL 508. The next question is, what the heck is UL 508 and why am I interested in that? Well, UL 508 is your industrial control equipment approval. And if you're really interested in what they do, here's a snippet off of UL's website that shows you all the different kinds of testing that they run. And keep in mind, UL is not concerned with what the product does or really even product assembly quality, so long as you build it to their specifications. All they're really interested in is safety. Is this flammable? Is this going to spark, arc, cause fires, cause interference? Is someone going to risk touching a dangerous component? Will it get too hot? That's what UL is interested in. And what's nice about having the UL 508 industrial control equipment approval is you can use it in UL panel shops and the builds of UL panel shops without having to go out and get this retested by UL. So if you work at a UL panel shop, if you are a systems integrator or a skid manufacturer who likes to build UL approved panels, the fact that we are now a 508 industrial control equipment listed product means we are very easily able to be integrated into your systems without causing you a big UL headache. And if you are a distributor of ours who calls on UL panel shops or people who build UL systems, this is absolutely something you should let them know about. One thing I will note is that along with the industrial control equipment approval, we are also now UL Type 4X. And that is essentially the same thing as NEMA 4X, which is that waterproof and dust tight approval. It means you're waterproof to everything essentially leading up to submersion, and you are dust tight. But UL does their own testing to essentially the same NEMA standard. Whereas NEMA is a self-declaration, UL Type 4X means UL has tested it and UL is putting their mark on it. So it also offers a nice, trusted third-party verification that it does have that NEMA 4X seal on there that we claim it does as Precision Digital, because UL is also putting their name on it and their Type 4X approval. Getting into the hazardous area approvals for a moment. Again, you've got CUL and UL for Canada and the US. And we have Class 1, Division 2, Class 2, Division 2, and Class 3 approvals. And what does that all mean? Well, your classes denote the type of material that's present that's hazardous. Is it a gas? Is it a liquid? Is it a fiber? Well, we cover you for all of those. And for the cases of Class 1 and Class 2, Division 2 is defined for those classes as an area where the hazard is only present under abnormal conditions. So in other words, the way I like to explain this is, let's say I have a tank out in the field, because level is by far the most common application I think we run into here. Let's say I have a tank out in the field, and it's got some kind of flammable material in it. Let's say that tank is filled up with diesel fuel. And I'm going to put a level transmitter through the top of that tank. And I can see the people already writing in the comments. I know my drawing is incredible. Please try to stay focused on the presentation though. I can draw for you after it if you want to stick around and we can just enjoy that. But imagine I have a level transmitter connected up to this tank. Well, that level transmitter is going through the tank wall. It's going into this Division 1 area where I have this flammable liquid and it is giving off hazardous gases, and that's just there all the time. There's no time at which being inside of that tank is ever not going to be hazardous. So inside of that tank is your Division 1 area. Now, outside of that tank, ultrasonic level transmitter in here, a little better. Outside of that tank, I want to have a control station where people can see what's going on, because I have some pipes running out of there. For this real simple example, we'll just put a manual valve over here that's running to a truck loading and unloading station, let's say. Well, I can say that the insides of that tank are clearly Div 1. However, on the outsides of that tank, I might have exposure to that hazardous material. What if this valve leaks? Or what if there's a spill at the truck? Or what happens if some junction with the tank is a failure? Or somebody leaves a vent open? Or there's another kind of spill from the top of the tank? There could be a scenario you could imagine where I would have those hazardous materials nearby. So when I want to add my control station here so that people can see the levels in that tank, I want to put my ConsoliDator Plus right next to that tank. Well, that's now in a Div 2 area, because it could be hazardous, but it generally is not unless something's going wrong already. The reason that distinction is necessary, why I'm giving you this whole explanation, is because if you are going to be installed in a Division 1 area, you need an intrinsically safe product, IS approved product. If you are going to be in the Div 2 area, then that's a different story. If you're going to be in that Div 2 area, all you need is a Division 2 product with non-incentive approvals. And the main advantage of that, so I guess I'm going to draw these again. The main advantage of having that Div 2 approval on your tank is that I don't need to have barriers in order to go out into that safe area now. So I could say, for me a moment again while I redraw my Division 1, Division 2 lines, that everything sort of in that tank is going to be my Division 1 area. So my level transmitter has to be Division 1, But everything outside of that tank, including my consolidator I've mounted, is division 2. This is my div 2 area. This is my div 1 area. And when I then say I want to run signals from that consolidator plus back to my control room for power or 4 to 20 milliamp retransmitting outputs or Modbus signals or relays back to the control room, I don't need to use barriers on these signals when they run off to my safe area, which is where I've got my PLCs or my big computer monitors back in the control room. Now, I do need barriers to go to an intrinsically safe product. Almost everyone I've ever seen requires you to have a barrier there in their control drawing. But you can install a non-incentive div 2 product in the div 2 area without any special barrier requirements. And so that's just saving by having that specific div 2 non-incentive approval. You're saving the need to have a bunch of barriers going between your safe area and your division 2 area installation. So I know that was a lot and a lot of scribbling on the screen, but hopefully it does help explain why it's so important for us to have that div 2 non-incentive approval. It saves you a lot of time, effort, and money specifying, buying, and wiring up barriers to get all those signals back out of the division 2 area into your safe area. The other new physical feature, we'll call it, of the Consolidator Plus is that need to specify AC or DC power. It used to be that everyone would have both, and you'd have another connector up here for AC powered ones that would let you have DC. Well, now you have to specify when you buy, are you getting the high voltage AC powered one, and you're getting the connector for high voltage AC power, or are you getting a lower DC powered one, and you're going to get the DC voltage connector on there. Not a huge difference as far as functionality goes. It's really just when you buy the product, you got to know what it is that's going to power it up. And there is an adder for that DC power. There is no adder for the AC power. So your DC models are going to be slightly more expensive than your AC powered model. Both come with, in fact, I see a question just came through from Devin. Both come with 24-volt power supplies for all your analog inputs and outputs. That is not impacted by whether you're using 24-volt DC power to run it or you're using higher voltage AC power to run it. All the specs are the same, all the features are the same. It's just a question of what you're using to power the unit. Now let's talk about the actual feature changes, the software feature changes, you might say. So we have added PID control for multiple control loops, and that stands for proportional integral derivative control. That's the type of control you use when you want very precise set points to be met, and you don't want the ups and downs that you might get from, say, the thermostat in your office. You want very precise control, usually out of devices that can take advantage of, say, being 60% on. These are not on-off state devices. These are things that can be on at a variable level of on. And so what does that look like? And what can you do with that? Well, this gives you an idea of what a simple PID control screen might look like on the front of the consolidator. Here we've got it labeled just as PID control 1 to make it simple, but that could be related to your process, but typed in label for the screen. Here we've got our process variable. We're doing a temperature application here. So we're displaying it in temperature units of Fahrenheit, and it's currently 80.3 degrees. Then you've got your set point. That's the level at which I want to control my temperature. So I'm currently 80, but I want it to be 90. And so my power, the percent that my outputs are being driven, is currently at 60.5%, which I think is going to bring me up to that 90. And most likely that 60 is going to go down a little bit before I hit 90. Now, how does it know that I need to be at 60%? Well, that's what the proportional integral derivative algorithm is all about. That's what's going to calculate the power needed to get exactly to that set point. Hardware-wise or signal-wise, how does that work? Well, we've got 4 to 20 milliamp outputs that can be used for what's called SCR control, or silicon-controlled rectifier control. Traditionally, that would be going to a power controller to control the amount of power going to a heater, but it could also be the 4 to 20 milliamp output going to a valve positioner or actuator to put a valve at 40% open. Or it could be going to really any kind of device that's going to take a 4 to 20 input that is then going to control your process. So it could be going to an SCR that's doing pulse width modulation for a compressor. It could be going to even a lighting system, for example. It could be almost anything that's going to take that 4 to 20 and use it to drive your process variable up or down. We can do pulse width modulation or SSR control. SSR stands for solid state relay. And in traditional PID controllers, that's the terminology you see. But that SSR output really means pulse width modulation or time proportional control, where you're sending quick pulses out to drive that device. You could be sending pulses to a solid state relay that would then be controlling a resistive heating element. Or you could be sending pulses to a motor to control speed. Anything that's going to take that pulse, whether that pulse is a cycle every second or a cycle every 5 minutes, and use that as a means to control the level of output of that device that's raising or lowering the process variable. We are a heating and cooling controller, so you can drive that process variable up and down. That's what heating and cooling means. Again, generally PID controllers use heating and cooling kind of terminology. They use temperature terminology, but it could apply to level, flow, really anything where you have a system that you want to drive and control the output to a specific level. And thanks to the switch functions, you can very quickly change between specific preset target set points. You can easily switch between auto and manual control, and you can punch in new set points easily thanks to our soft keys. In fact, that's what we're doing here on the left. We've got this screen set up with what we call PID Tuner, which swaps me into manual mode, so I can manually drive it up or down a little bit if I want to make adjustments. We've got our auto tune button, so if I want to auto tune this process often, I can. If I just want to do it once and forget about it, I can always institute the auto tune and then replace the soft key with something else. And we've got a button we just call set, which is used to change our set point. So we just push that and plug in whatever we want our new set point to be. Here's some screen examples that we've seen with PID controllers. So here I've got my PV average, because many times in applications they want to bring in multiple thermocouples or RTGs, bring those in through temperature transmitters because we do not take temperature directly in, and then average out those signals. If you've got a vessel where you think that you're going to have some temperature distribution, you might want to have 2, 3, 4 different probes in there and average that out for your temperature. And then this screen is also displaying active set point, letting you know what the active set point is I'm trying to control to. And it's showing you that power level, so I know where I'm at as far as how hard I'm driving my devices. And in this case, I happen to be stopped. I can, of course, easily just go turn that on with my soft keys. On the next screen, you see multiple set points. You can jump between pre-programmed set points easily using the switch functions. And in this case, we've got our function keys assigned to start PID control, change step point 1, change step point 2, or go to the next screen. So here I'm showing multiple PID control loops running, so I can start and stop them all at once, or I can change specific set points. It's worth noting that that power channel can actually go negative as well if you're doing heating and cooling control. So in this case, our power is -100 because we want to be driving the cool side of this, because we're trying to get it down to 0, but we're only at 23 so far. So it's driving maximum cooling power to our temperature process. 100% would have been maximum heating process, -100 is maximum on the cooling side of the process. And if I'm doing pulse width modulation control, it's the same thing. You're still just talking a power percentage. However, you do have these on-off states you cycle between. And so someone might want to see the on-off states of those individual heating and cooling sides when they're doing that pulse width modulated control, when they're pulsing things on and off over some kind of cycle time. Especially with mechanical relay driven longer cycle times, people might want to know if power is currently being applied to that fan, that valve, that heating element. But just some examples of what you might see on screens. There's an infinite number of ways you may choose to set those up. To give you an idea of what these look like in actual applications, here's a couple of simple PID control diagrams. Again, using temperature because it's easy to understand, but it could be any application. So here we've got a vessel in which we've got an electric heating element. And we have one temperature sensor in that vessel, which is being taken in by a temperature transmitter. Could be a simple little hockey puck transmitter. It could be one of our own displays that displays it locally to the vessel and then provides a 4 to 20 output. But either way, we get that 4 to 20 and we bring it into our ConsoliDator Plus, where we read it in as a channel with its units. We probably display it, bring it into the PID algorithm. And then we're using a digital output to pulse width modulate drive a solid state relay that's very rapidly providing an on-off signal, which is turning power to the electric heating element on or off. So you can imagine me quickly pulsing that heating element, so it's not going to get as hot as it could possibly get. It's going to reach some kind of intermediate point. So we're going to feed it, for example, 40% power, and that's going to be as much as we need for this heating. Making up 40%, it could be any percentage, but that's why we're pulse modulating it, to bring that heating element up to some temperature that isn't just fully on or fully off. Now, if you want to get a little more complicated, that's possible here. This is an environmental chamber where they had 2 temperature probes, a primary and a backup. They weren't actually averaging on this one. Again, each one of those went into a temperature transmitter. Temperature transmitter then sent the 4 to 20 milliamp signal into the ConsoliDator Plus. And in this case, again, the idea was not to average. That's usually what you see. But instead, the idea here was they wanted to have a primary temperature sensor that they would always use, but then have a backup in the case of the first one failing. So if the first one failed, we have functions in the consolidator where it can then switch over and use a different input for its PID control channels. And then they'd switch over and have their backup there and have an alarm go off saying, hey, the first temperature probe has burned out or had a failure, please replace it. Now that we've got our process variable coming in, we're using our digital outputs again to drive, in this case, 2 solid state relays, one of which was pulsing the heating element, like we just discussed a moment ago, one of which is actually providing a drive for a motor, which is controlling a compressor. And that side was responsible for cooling down the process. So if you need to heat up, it's going to drive digital output 2, which is going to trigger the solid state relay to give power to the heating element. But if you need to cool things down, you have the same basic process on the compressor side. And then talking about 4 to 20 milliamp outputs for a minute. In this example, again, we've got that same environmental chamber with its 2 temperature sensors going through temperature transmitters, outputting their 4 to 20 milliamp signals to the ConsoliDator Plus. But now we have a 4 to 20 milliamp output going to an SCR power controller, which is controlling the power getting to the heating element. And then we've got a 4 to 20 milliamp output, which is going to a valve actuator, which is allowing through a certain amount of flow of chilled water. So in this case, they've got a heat exchanger. These are industrial applications. You know, these are not your benchtop temperature chambers. But they wanted to, they had a chilled water input, and you control how much flow is going through there by essentially controlling the position of the valve as your regulator. And that was done by a 4 to 20 out. All sorts of different ways you can do these controls, all based on the application that you have. But the core PID functionality is all in the ConsoliDator Plus that determines what those output levels should be, what those inputs are going to be that go to that channel, and give you the ability to set those set points and control it. Then you've got your digital switch functions. Well, these are great for HOA switches or handoff auto switches. And briefly, just to touch on what that is, your hand mode is manual on. That means you're forcing the relay to turn on. Your off mode means you're forcing the relay to turn off. And your auto mode means you want this pump to be doing whatever it is it should be doing based on the level. So just do its automated pump control functions regardless of what you may want. HOA switches are extremely common in pump control, and it's just a terminology that we see used all the time. But really, you could use this for any function. It doesn't have to be pump control. It's just primarily what it's used for. And so here we've got a screen showing HOA pump 1. Now, that's just what we've chosen to name it here. In an actual application, you would have something specific to your application. It wouldn't mean anything for me to put something up here that says, you know, pump P16. You know, so we try to put something on the screen for purposes here that show you what we're doing. And then I've got my channel label. So here's my tank 1 and level in gallons. Again, nice commas and decimal points so I can really understand the numbers. We're giving you the data for pump 1. Not only that it is off, but also its run and cycle, runtime and its number of cycles. Great information for maintenance purposes. We're letting you know that if it is set to auto, it would be calling that pump to be on. However, the HOA switch position is currently off. And I changed that by hitting my soft keys down below where I have hand, off, and auto. So I can control pump 1 either by letting it do its own process for pump control or by forcing it off or forcing it on just by hitting buttons on the screen. A little schematic diagram just to touch on what handoff auto is again. So this is what your schematic of a handoff auto switch would look like, where you've got your, in our case, a digital switch, but theoretically a mechanical switch here, excuse me, that you are toggling from either off, where no power is reaching that motor, to hand, where you are forcing it to be on, you're just hardwiring it to on, or you're switching it over to auto, where it will either be on or off depending on what the pump controller is calling for. You set those up very easily. We've got ways to set up 2, 3, 4-way switches. You tell it what each position is going to be called. And then if you want to, you could have actions take place when you go into those positions. So for example, here we've got pump 1 manual, pump 1 off, pump 1 auto. That's what we've named them. They're going to show up as soft keys as manual, man, off, and auto. And when we switch into those states, we want to either put the pump in manual on, manual off, or automatic mode. We build all of those inside of our switches menu setup. Now I could use 2-way or 4-way switches the same way. So for example, here's a switch that's just going to allow me to select between 2 sensors. That's all it's going to do. Or I could have a 4-way switch. It's going to allow me to switch between those 4 sensors. And every time that happens and I make one of those switches, I want to manually turn on a relay that's going to turn on an LED. So I'm going to know on the panel, a light will light up to let me know which one of these RTDs it is I'm selecting from, either because they're in different processes or they're different locations in there. Lots of ways you could choose to set these up. Now, a lot of you, at least half of you, were from our distribution channel. So it's worth taking 2 minutes here at the end of the presentation before I do questions to talk about our demonstration unit. This is a great way to show the Consolidator Plus in person to people. It comes in this handy package where we show the back of the panel and how it all mounts so that everyone gets a clear understanding of how it works and what the physical nature of it is. But we put it on mounting feet so it'll easily stand up on the countertop for you. And we have a bracket that we make that mounts a light and horn here so you can show it triggering relays, setting off alarms, setting off lights. Our PD9000 4 to 20 milliamp signal generator provides a signal into it so you can actually toggle the 4 to 20 milliamp signals up and down and trigger those relays, trigger that pump alternation, show how all these different channels would work, show how the timers work. We've got gas detection examples in here, Modbus examples in here, flow, level, temperature, bulk solid monitoring bins to replace LED bar graph meters, all sorts of interesting screens pre-built into this demo for you to show off its capabilities. If you're interested in something like that and you want to show it off to customers, let me know. We'll work out an arrangement. We'll get you one, let you start showing your Consolidator Plus to folks ASAP. So with that, there are a couple of questions here. Some of these look like they are really in-depth application questions that I will not be able to address live, but some of these I certainly can here. And so let's start going through a couple of those. I appreciate it for those of you who have been waiting around. I know I was pushing through the content pretty quickly. So Albert is asking, is there different levels of security so operators cannot change some set points? And you can't lock in specific set points as being password protected, but you can password protect the setup. So you could, for example, pre-program in certain set points or even have the general entering of a set point available by the soft keys and just have that be your configuration, but lock down the setup so that they can't go screw with other things. Or you could give them access to just a couple of set points that they choose from and they don't have access to change the set point in general. So there is a password ability to protect the unit. And by choosing what you give access to the operator to do through the soft keys, you can restrict what they have the ability to access. I hope that answers your question for you. If not, do me a favor, just chat back in and let me know. And then Eric is asking, do we have any intention to get zone approvals? And then in a separate question, also ATEX and IECEX. So right now we have classes and divisions. I know that the more recent approvals that everyone's pushing towards are zones, even UL. But traditionally in our industries, we see class and divisions. And so that's what we've chosen to get for UL and CUL. That's not to say in the future we may not have ATEX, IECEX, or zone-specific approvals, but we don't have any of those projects open with agencies right now. There's currently no roadmap to get there. If we see the need and the demand, then great. So if you have a application where you need this or a specific reason you're asking, go ahead and let us know. That's how things get on our roadmap for future product development. And I have a question from Thomas, different Thomas, spelled differently than earlier, about how many pieces of information can you show on a screen? Is the 8 pieces of information bar graph and the numerical display that I was showing earlier, or would it be 8 bar graphs and 8 numerical displays? If I understand your question correctly, I think that's what you're getting at here. So what I mean is that you could actually show 8 channels or 8 channels or plus alarms, plus relay status, etc. So for example, this screen in the upper left is showing you 4 of those 8 pieces of information. We're showing 4 channels right now. So I could add an additional 4 channels where it's just going to essentially cut the size of each one of those boxes in half. And you're going to have 8 numeric listings over here on the right, with each one having its information, its channel, its digits, and its units. And then I'm going to have 8 bar graphs squeezed over here on the left. So if you show bar graphs for 8 items, you'll see 8 bar graphs and you'll see 8 pieces of information listed on the right. Keep in mind, it does not have to be channel information like that, input information, you might say. I could have that reading out all sorts of different information. Like we showed at one point, an example on the HOA pump screen where we were showing the pump runtime. That would be one piece of information that I could have up there. And also, not everything has to have a bar graph. So I could put 3 input channels showing tank level or temperatures or gas detection levels. And then I could also choose to put on there things without bar graphs and have alarm statuses and pump or relay run times and cycle counts and statuses of those relays is on or off. Those things obviously wouldn't need bar graphs, but I could put them on that channel anyway. And I would see my 8 numeric pieces of information and then the 3 bar graphs next to that. So the display is very configurable as far as what you want to see and how you see it. And it has the smarts in it to choose, okay, this is the best way to display that. This is the ideal size for that, and render it all for you without you having to like code up how you want it to display like you might with a real HMI. With that, folks, it is well past our 45 minutes. I thank you for the time you have given me this afternoon. I hope that the Consolidator Plus is of interest. I hope these new features are of interest. If you have an opportunity to use them, I urge you to reach out and talk to us about any questions you may have. And once again, before I let you go, there is a survey you may see at our close here. If you could fill that out, I would certainly appreciate it. That information is very valuable to us and does help us prepare future content that you want to engage with. So I thank you very much. I hope you fill your surveys out, and we'll see you at our next presentation. Thank you.